All right, 2C here on the green worksheet for 10.5 is a bit abstract. They tell you n plus 1 factorial over n minus 1 factorial. So we don't know what n is. We use n a lot in math to generalize. That means it will work for any number. So before we do that, perhaps we'll use actual numbers to see what's going on here. Pick a number for n. All right, I heard 4 first. If n was 4, what would the numerator be? 4 plus 1? 5 factorial, right? So the top would be 5 factorial. The bottom would be 4 minus 1, which is 3 factorial. If you expanded this, right, what's on the bottom? 3 times 2 times 1. Who would cancel? The 3, 2, and the 1, and you'd be left with 5 times 4. Would this be much different if n was 14? Well, a little bit. What would the top be? 14 plus 1? 15 factorial. Bottom? 13 factorial. So it'd be 15 times 14 times 13 times 12 times 11 times blah, 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 all the way down to 1. While the bottom would be 13 times 12 times 11 times blah, 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 all the way down to 1. You would still have all these cancel except the original n that you chose times n plus 1. One more. So let's go back over here with the actual letters. n plus 1 factorial means start with this times 1 smaller than that. Well, what's 1 smaller than n plus 1? N. Times, what's 1 smaller than n? Times n minus 2. All the way down to, where do you always stop a factorial? When it gets to 1. Okay? On the bottom, you're starting with n minus 1 times 1 less than that, n minus 2 times dot, 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 n minus 3, all the way down to 1. Who cancels? Everything. N minus 2, n minus 1. The only thing that doesn't cancel is n plus 1 times n. So that is your final answer. N plus 1 times n.